Well, hello and welcome back to the Tin Barn. I'm Pragmatic Lee again, and we're continuing our series on the build of this 2x72 inch belt grinder. You might can see in this video that the belt grinder is getting a little bit dirtier as the parts proceed. That's because I'm using it. I'm getting a lot of use out of this, use I never even dreamed of. But in any case, we're going to continue this build process today, and today we're going to look at the structure itself. For the purpose of this, I'm just going to give a quick label to the parts of the structure. We'll call this piece right here simply A. This is the piece that the plating rod mounts into. The work platform B, the column will be C, this foot will be D, and then we have the male pieces that go with them. I've received several requests for drawings, plans, and I hope, and it's my goal, that by the time I finish this series, finish the video series of the build, that I'll have a set of drawings made. They may be crude, but in the meantime, I'm going to try to give some dimensions. First off, this piece of hollow structural steel, that's what this is called, A, is 2 inch by 2 inch by 10 inches long with an 1.75 ID. So that means each wall is about 125 thousandths thick. B, the piece that the work surface slides into, is the same size, 2 by 2 by 10 with an ID of 1.75. C, the column over here, is also 2 by 2 by 10. It's the same thing, 2 by 2 by 10 with an ID of 1.75. The foot down here is 2 by 2 by 4 inches long, and that's the same material, 1.75. By the way, I got all this material from SpeedyMetals.com. The male piece that slides into A up here, that the plating and the backing plate is mounted onto, it's 1.75 by 1.75 by 17 inches long. That may have to vary based on where you set your drive pulley back here, drive wheel back here, that overall length. But 17 inches is a good point to start with. The piece underneath that the work platform, that the work bench is mounted on, is also 1.75 by 1.75 by 18 inches long. I bought both pieces 18 inches long and cut an inch off of this one. The inside of the column here is 1.75 by 1.75 by 13 inches long. And the final length of that may be a little bit dependent on what size spring you get that goes in the bottom down here. So we're going to look at a quick video on the structure and be back in a little bit. The overall frame of this belt grinder, will be constructed with hollow structural steel. I'm using 2 inch outside diameter, 1.75 inside diameter. You'll need, of course, on the plans will show you these pieces for the top one will be where the plating will attach to the arm that slides in that, and the bottom one will be the workbench. This is 1.75 inches, which by size should slide into there. But I bought this material from SpeedyMetals.com. I'm not affiliated in any way with them. They are a good source for individual short pieces. Their website says absolutely no minimum order, but in any case, they give you a warning on there, or not necessarily a warning, but a disclaimer, that if you want one to fit into the other, you're going to have to do just a little bit of work. Let me tilt the camera down just a little more. As I say, by dimension, one should fit in the other. But there's two issues there. Number one, this is concave just a little bit here on each side where it was rolled. So on the edges, yes, it is 1 3/4 inches, but in the middle it's rolled in just a little bit. You can actually feel it in there. The second thing to concern about is the weld joint. There's a weld in there. Now, these pieces are, let's see, I cut and squared them off to 10 inches long. It would be very difficult, practically impossible, to get a Dremel up in there to try to flatten that out. So what I'm going to do, I'm going to take the Dremel and work just what I can reach in there comfortably at one end, just so the weld is not an issue at this point. But the first thing we're going to tackle is the overall dimension to take care of that concave. So I'm going to carry this over to the milling machine. As I say, these are 10 inches. The receiver portion of it is 10 inches long. So we don't have to worry about anything more than 10 inches. So I'm going to mark about 10 and a half. And I'll mark approximately halfway on that. Now I'm going to carry this over to the mill, and we're going to put a large end mill in there and take some of this surface down off of all four sides. We'll trial fit it in there, see how it fits, and continue to work that down. I've got one of our smaller pieces, the 1 3/4 inch piece, over here in the lathe now, in the mill, I'm sorry. You probably can't see it on there, but this is our 10-inch mark right here, 10.5 inch from this end. That's the mark that I put approximately halfway, and I did that just to get that centered on the vise itself, approximately centered on the vise. So what I'm going to do is touch off here. Now we don't need to take a whole lot. Probably about 18 thousandths off of each side is going to be sufficient. And this is, of course, it's hollow, got a lot hanging out there, so I'm only going to take about 10 thousandths at a time. So I zero out the DRO there. Get one of my old shop rags and throw down here, because I'm going to be using the mister on this just to keep it cool. But we'll come off the end. And like I say, come down about 10 thousandths to start with. And we'll engage the table feed. When I get to that 10.5 inch mark, I'm just going to run it back and forth on the y-axis to get a good perpendicular start and stop line there. And then of course we'll go back the other way. I believe I can increase the feed rate some. I believe I could have probably took the whole 18 thousandths off at the time. That's cutting very, very smooth, not getting any chatter or any vibration in there. So I'll finish this side, take another 8 thousandths on this side, turn it 90 degrees and repeat the process. Okay, I'm fixing to start on the fourth final side on this piece. Not really sure what I was thinking when I said only going to take half the cut at the time. I guess I was thinking 180 thousandths instead of 18 thousandths. We're only taking 18 thousandths off per side. So obviously the mill can handle that much at the time, and I increased the feed rate considerably. So once I make the 3 passes on this, then we'll test fit our female piece that goes with this. All right, I believe this is in frame now. But as I said, I took the Dremel tool and knocked down that weld joint in there. Weld joint's not very high at all, but I knocked it down right there at that end so it could test fit. And that's a good fit on there now. While I'm set up for the to do this with the large end mill, I'm going to go ahead and do the mill piece for the one of these long ones will be for the plating and the other one for the workbench, and then there'll be another of the smaller pieces for the column, for the upright column. So I'll go ahead and do those and then come back when we actually start working on the second problem with fitting these in, and that's the weld joint in there, how we're going to take care of that. Okay, I've got all the pieces roughed down now, or smoothed down. Got the sides cut so that they fit in there. Now we want to handle this weld that's in there. Now if you notice, well, let me say this first. Don't try to make a production run out of this if you're doing this, if you're following what I'm doing here, because the weld joints in these 2-inch pieces is not in the same place on each one. Probably would be if it was all out of the same run. But if you notice this one over here is very close to center. This one is almost 3/4 of the way over. So once you've got your male pieces done, your smaller pieces, match them with the larger piece. And they'll stay together for the remainder of that project. So it's obvious, it's easy to see here where the weld joint is. I'll mark about the center of it. All right, I think I have this where you can see it, actually see what's going on now. And again, I marked the center of the weld. And I'm going to come right here and put just a little mark on there. Now we'll run this down and center the roughing end mill over that mark I just made. We're only going to take out probably about 20 thousandths here. I'm sorry, about 30 to 40 thousandths out. It doesn't matter. It's not going to ride on that weld joint, we hope. There's about 40 thousandths. And once I get that cut through there, matched with that piece, if there's any rubbing or whatever, I can carry it over to the horizontal belt sander I've got over there, the little Harbor Freight one, clean it up. If it's very much, I can run it through with the end mill again. See, I believe I'll speed that one up a little bit. Alright, let's see how that matches up with the piece that we mated it with. A little tight right at that end right there, but I don't think it'll, well, right there is as far as it can go anyhow, so that last ½ inch. So that works fine. Very little play at all in there. I'll do the same thing on our other two pieces and be back for the next part. Alright, I'm over here now at my little X2 mini mill that gets used primarily as a drill press now, precision drill press. But got one of our nuts that we made earlier, and I've got the first hole laid out there, got it center punched. So we're going to drill and tap that. And I'm mounting these with a 1024 screws. And not that it really matters, but I'm putting the weld joint to the bottom. Alright, now that I've got one drilled and tapped, I will go ahead and mount that. And I'm just lining this up by eye. Alright, I'm going to tap this one and then drill and tap the other two, and we'll mount that on there and be back in just a second. Okay, I just realized I had the camera zoomed in very tight. You may not have been able to see a whole lot of what was going on there, especially in the tapping part. But what I'm using to keep the tap straight is a spring-loaded tap guide. And most tap handles and mini taps have a hole in the back of it for this very purpose. Being spring-loaded, just put pressure down on it. And once your spring runs out, of course, you can lower your head down. All right, I can feel some little burrs under there, so I'm going to turn this over right quick and take the Dremel tool in there. Well, there's really no need of doing that. What I'm going to do is mount the block on there, mount the nut on, and then if the screw sticks out any on the inside, I'll take the Dremel and clean it all up at one time. And I don't feel anything sticking through there. So let's see. Yeah, I think there may be one little burr on there. Now, each to his own. But I think that right there will look a little better than a nut welded on the side and a bolt with a T welded to it. So I'll continue to do the same thing to the other. This one is going to be, I've got this these paired together. This will be the plating and I'll do it to the work shaft bracket, and also to the upright column. All right, I took the piece out and carried it over to the other workbench. Got the Dremel on there and cleaned it out, cleaned the burrs off. So we got a good slide now. And obviously, in order for this to bite down against that and hold it, there needs to be a hole in the center here. So I've got a center punch now that I've got that mounted, or I've got a transfer punch. Just gonna give just a tap it. Now we can remove this. And these holes should be symmetrical, but just in the event they're not, I'm leaving one screw in, and I know that will be to the inside one. Now we're going to drill that for a 1/2 inch. I believe as thin as that material is, I should be able to drill it without a pilot hole, without a lead hole, but we'll see. Slow it down considerably. After everything is painted, powder coated, or whatever I decide to do to this, these screws will get some Loctite in them. So now, this should be able to go all the way through and clamp down, which it does. All right, as I said earlier, I'll complete that process on the other pieces as well. The upright column on the grinder will have of course, an insert that rides in that the tracking roller will be mounted on the side of this, or off to the side of this. This will be sitting on a spring in the bottom. Maybe 2 of them. This is just according to how much strength I get out of that. I may set 2 of them in there. But in order for that to ride on that spring, this needs to have a bottom in it. So I'm going to swing the camera around to the milling machine. I have a piece of material set up in there now, and we're going to cut a bottom for this, and then we're going to actually pin it in. I'm not going to try to weld it. I'm going to use these spring pins. This is a 3/16 by 5/8. I'll put one on each of the 4 sides. The pieces need to be 1.530 square. So what I've done, I've got the slitting saw in here now, and using one of my parallels, I'm just going to bring that slitting saw down to there, and then zero out the DRO and come down 1.53. All right, I put a little mark on there, and that looks good. So what I'm going to do now is use the slitting saw, and this is the first time I've used this arbor. Really don't know enough about using a splitting saw to know what speed I should be running in. I'm going to try this at 220 RPMs. To start with and see how that goes. Okay, that is through the back side. I'll lock the y-axis down and then just gradually feed in. That is sending some pretty hard, some pretty hot chips right my way. Okay. Being that scrap piece like it was, there's nothing holding that backside there and it bit into it, but no harm, no foul. I'll check this diameter now, and that piece is hot. I'll check that, be sure it fits in, set it up, and cut it in the other direction after I cool it off a little bit. Okay, I have the piece milled down now to where it fits in. A 2x72 belt sander would have been an ideal tool to have around the corners off of that piece to get it to fit in there, but a little grinding work and it's in there. I'm going to drill all the way through, turn it 90 degrees, drill all the way through again, and then we'll install the spring pins. Alright, I'll carry that over, deburr it, and then we'll go back to the workbench and put the spring pins in. Alright. Take our spring pins, and these happen to have one end that's tapered just a little bit more than the other. We'll drop the spring in there. Now, that will give us our tension on the tracking roller. More work on the column here. I went ahead, just like we did on the bottom, and put the spring plate on there. I put one in the top too as well. Pressing down on that, side's a little bit rough on the hands, so I cut a piece out again, just like I did before, but drilled and tapped it in the center. And this is just a little ball I had around here. It's a 1-inch ball. Don't think it's going to be big enough, but it's just something in there now. That's a pretty hefty spring in there. But what we're going to continue on to do right now is put the finish the mechanism for the tracking roller. This is again a piece of the same 2-inch hollow structural steel that I've cut on about I believe that was about a 40-degree angle on there. Let me look right quick. that's about a 43-degree angle. Basically what I could do in my saw. The tracking roller, remember this is the one that's got the bevel on it. It's going to mount just like this. The axle will be through there. There'll be a bushing in between here, undetermined length at this time. Won't know that until we get everything put together. But then a nut on the outside out here holding that. This will be mounted on the side here and will be able to tilt back and forth. That will rotate back and forth through this T-handle, the long T-handle we made before. This nut will be mounted on here on the side. See if I can get my hand out of the way. And then this will thread and push through there and rock that back and forth. This is basically just going to be drilling some holes and running the pin through there. So I'm not going to video all that, but I'll bring you right back to this before we put this piece to rest. And I finished drilling the holes in the column now. And as you can see here on the back side, I have drilled and tapped and mounted one of our nuts that we made earlier. This has a 1/2-inch hole on this side. This side over here has a considerably larger hole. You'll see why in just a moment. Then also a couple pass-through hole at the top here. This is 3/8. That mounts on our spring. Now for right now, for the axle, well, here's the other piece. Drilled here for the axle for the tension. I mean the tracking roller. This is where it'll go, and then pass through holes up here where this will pivot. For the axles, using a 1/2-inch bolt, and I carried this over to the lathe and knocked some of the edges off of it. Left enough on there, so left enough of the hex so I can still get hold of it to tighten it. But I wanted that rounded off some, and rounded this in. I also put a little bit of relief right up at the top up there to be sure if there was any shoulder in that I took that out. So that goes through as such. As you can see, I got a good seat on that with that relief in there. Now this will mount with just a 3/8 bolt. And again, the bushing will be, the length of the bushing will be determined after I get everything put together and on there. Right now, I've just got a drilled out 1/2-inch nut where I just drilled the threads out. Put that on there, the tracking roller, and then this is another drilled out nut, just something to hold it together for right now. A few washers on there. Then the long T-bolt, T-handle that we made goes through here. One thing right quick, the reason this had a larger hole in this size over here is so that head can go in there if we need negative amounts in there. And I need to tighten that just a little more. But as that tightens through there, you can see how the tracking roller will raise up and down. Not sure, but I may need a lock nut on this side over here. We'll just see how, with the spring tension, I believe it's going to hold it though, once we get everything locked into place. All right, all these pieces that we just got machined so they fit inside one another and work together nicely need to be put together. And I'm not a welder by any means. I was able to stick this together. I did not try to video the welding. I did get some pictures of the layout of the way that I laid it out to be be sure it will square. My welder is not one of these fancy newfangled TIG MIGs or anything like that. It's about a 35-year-old Lincoln 225 buzz box. I've had it for over half my life and never really burned probably more than 100 pounds of rods through it, but it serves the purpose. Also, you'll see in that where I put feed on the bottom of this, or plate on the bottom of these, instead of welding it down to a surface. First off, this is an aluminum plate that I've got it mounted on, so it's not feasible to weld the steel to the aluminum. Plus, I wasn't sure that this is going to be the final resting place for that. So you'll see that I weld these 2-inch wide by, I guess they're about 4-inch long by 1/8 inch thick flat bars on the bottom to use for feet. So I put together just a few minutes worth of pictures of the layout and the welding. Okay, hope you enjoyed that segment on the structure of putting it together, making the pieces work together, and then the pictures of the welding. This is going to conclude this third part in this series. The next part in this series will be the layout or the building of the plating itself. Right much machining and drilling on the plating and the back plate. So stick around, in a few days, part 4 will be out.